So today we're doing problem set 1-4, measuring angles. So most of you know what an angle looks like. We have a little angle here, and it is formed by two rays with a common endpoint. So we need to make sure we're calling it by the right name. So when we talk about the sides of the angles, we're talking about these rays, and the vertex is the common endpoint. So this point A on your angle is your vertex. So when you name an angle, you name an angle with a letter name. So this could be angle A. Or we can use three letters to name it. We could start B, A, C. Always your vertex is in the center. Or we could have started at C, A, V. So either way, my vertex is in the center, and I can figure out which angle I'm talking about, because not always will we have a single angle by itself. Interior of an angle, when we're talking about interior, it's what's inside of the angle, between the two rays. We talk about exterior, it's on the outside of the two rays, not between them. So those are all important things to remember, because we'll talk about interior and exterior of other angles a lot. So in this drawing, I have more than one angle. So I could not call angle K, because there's this angle K with the number 2 in it, there's this angle K here, or there's the whole angle K. So I have to label it correctly. Sometimes they'll label it with a number and they'll say, what is the letter name of angle K? If I look here, my angle name is angle J, K, M. So J to K to M. You should be able to follow your letters and make the angle. The other angle over here, MKL or LKM. And then the whole angle JKL. So they can label them different ways. You can use a number in there. They can also use little arcs to show what angle they're talking about. All right, so if we're talking about a whole circle, we go 360 degrees. If we do half a circle, that is a protractor. And so they do a protractor postulate, because they're assuming you've never seen a protractor before in your life. The protractor, again, goes from 0 to 180 as you go around it. So every ray that can be paired with a real number from 0 to 180. So if you were to draw an angle in here and put it off, there would be a number measure from 0 to 180. That would match that angle. So we call it the protractor postulate. So we can also find the measure of an angle on a protractor. Normally you want to line it up with your 0 and then measure to the other angle, but if for some reason you put it in the middle of nowhere, you could still find the measure of the angle COD by taking the measure at C and the measure at D and subtracting them, taking an absolute value, just like we did in the line segment. Why you would want to do it that way, I'm not really sure, but just in case. All right, so types of angles. These ones you need to know for sure. We need to know acute, right, obtuse, and straight angles. Hopefully you already know some of these, and they are in your head that acute is less than 90. So your value of your angle would be between 0 and 90. So 0 is less than x, which is less than 90. To be a right angle, you need to be equal to 90. We mark a right angle with a right angle. So if I were talking about a right angle in a postulate, I would use that symbol instead of writing out the word right. Obtuse means that you're greater than 90, so your value of your angle has to be between 90 and 180. And to be a straight angle, it equals 180. And that would just be a straight line. Congruent angles have the same measure. So again, when we write measures of an angle, this time we use a letter M to designate measure of the angle. A equals measure of the angle B. If we're talking about the physical angles, then we'd use congruent between them. So angle A is congruent to angle B. So anytime we add or subtract angles, we use measures. If we're just talking about physical angles and comparing them, we can use the angles themselves. So angle addition postulate. Forgot to star that. Make sure this is in your notes. Angle addition postulate, if point B is in the interior of angle AOC, then measure of angle AOB plus measure of angle BOC is equal to the measure of angle AOC. So just like we had segment addition, we do angle addition. So B is in the interior, so here's my angle AOC, it was inside. So I can take these two angles, AOB and BOC, add them together to equal the whole angle. Hopefully that makes sense. The other thing in angles, when we compare angles, we can mark our angles. So if I mark this angle with an arc and this one with an arc, it means they're congruent to each other. So sometimes we go from the given information and have to mark it in our drawing, and sometimes it's in our drawing and we have to know that information from the drawing. So that's all your notes for 1-3 measuring, 1-4 measuring angles.